So similarly, momentum is a vector quantity. Now there's a physical quantity called impulse. Now impulse would be a vector or a scalar. To know that, we have to know what is impulse. Impulse represented by J. Impulse is force times the time. The force that is being applied on a body and the time duration for which it is being applied. That is impulse. Force times the time of application of force. Now time is a scalar quantity, of course, but force is a vector quantity. Now scalar into vector will be a vector. So impulse will also be a vector quantity. Okay? Similarly, weight. Weight is actually generally weight is referred as the force by gravity, the force by which Earth pulls us. If we are standing at the top, at the North Pole, we stand like this, and the force is towards the center of the Earth. This is the direction of the force. This is actually weight. The weight that we feel is actually the force with which the Earth is pulling us, the force of gravity. Generally, that's what weight is. If we are standing at the equator, we are actually standing like this, and the force of gravity is again towards the center. So when we move around the Earth, the direction of gravity, the direction of weight changes. It's always towards the center, but the direction in a sense changes, because this is southward, this is westward, this is northward. The direction is continuously changing, and we stand in this configuration, in this orientation. So weight, using the definition, will be of course a vector quantity, because the direction of weight is changing. Weight would be vector quantity. Similarly, thirst, as we have discussed before, thirst is actually a force, kind of force, resistive force. So being a force, it will be a vector quantity. Torque, as we had a discussion before, torque is force times the perpendicular distance of the point at which the force is applied from the axis of rotation. If we have a rod like this and it is rotating around this axis, and if we apply a force here, then force times the radius, the distance actually of that, the distance, perpendicular distance of the point at which the force is applied from the axis of rotation. That is force. It has a direction. Now torque is F cross R, and we have seen before how to calculate torque, and we'll do that in a greater detail once we start Newton's law. But in previously we have done it, and I have taught you how to find the direction of torque. So it shouldn't be a problem for you to realize that torque is a vector quantity, because we have learned about the direction of the torque. Similarly, momentum. Oh, we have done momentum. So angular momentum. Angular momentum is mv cross r, and again the two vectors we have seen the cross product before, and I have taught you how to actually the cross product. We'll learn in this topic how to find the cross product of two vectors. But previously we have talked a little bit on this, so I think you can figure that we have talked about the direction of angular momentum. So angular momentum must be a vector quantity. Now regarding this cross product and dot product, we'll do at a later phase in this particular topic. If you have not heard of it, don't bother. We'll learn it in the course of time. Similarly, angular momentum, angular velocity, and you can think of more quantities to which we append direction. So these are vector quantities. Now quantities to which we don't append direction, or the quantities which can be completely described only with the magnitude, direction as such is not required, those quantities are called scalar quantities. For example, you can give hundreds of examples in this. You can give mass, speed, distance. When we talk of distance, we don't append direction to it. When we append direction to it, that becomes displacement. So direction just have magnitude, 3 kilometer, that is distance. 3 kilometer northwards, that is displacement. Volume, think of more yourself, not think. Speed, distance, volume, mass, what else? It could be time, it could be length. What else? Think. Come on, it could be power, it could be energy, it could be temperature, okay? It could be current as well. Now current, you have learned a little bit about electric current in your class 10th. So you must be having idea that the current, suppose this is a battery, current comes out from the positive terminal of the battery and it goes all the way through the circuit and then enters the negative terminal of the battery. It doesn't have a direction. If you bend the wire like this, it will go in the direction following the length of the wire. So the direction of the current would change. As such, the current doesn't have any direction, but it does start from the positive terminal of the battery and goes to the negative terminal of the battery. So we don't describe that the current is moving towards north or east or west or south, because if we change the direction of the wire, the direction of the current changes. So we don't talk about the direction of the current, we just talk about the magnitude, and we know that it comes from the positive terminal, enters into the negative terminal, but we never talk about the direction of current. So that makes current a scalar quantity. Okay, so having discussed few of the quantities, whether they are scalar or vector, let's get into the mathematics of this. Because this, what we have learned now is definition. So let's move to understand how we will be dealing mathematically with vectors.